Okay, let me give you the elevator pitch. I did actually do this in an elevator, and the guy was so surprised, he got off on my floor, stepped out, and said, I've got to hear the rest of the story. I send brains to space.
Whoa.
Okay, what we do is we take a skin sample from you, we revert it to a stem cell, we promote it to an organoid, and we send it to the ISS for 30 days. When it comes back, splashes down in Florida, we pick it up. The brains, the little tiny brains that we've made out of your skin cell, they're about 5 millimeters in diameter, have aged, and they have aged cognitively 10 years, and they've aged biologically 80 years. So I can take your skin and I can tell you if you get Alzheimer's when you get to 80. And I can also uh, apply drugs and therapies to that Alzheimer's brain and see if it works a bit better or whether the drugs I'm applying are toxic.
Hello, everyone, and welcome to our Beneficial General Intelligence series. On today's podcast, I am thrilled to welcome a true polymath and visionary, James Tagg, a serial entrepreneur, physicist, inventor, and award winning author with over 200 patents, oh my, to his name. He exemplifies the spirit of a classical inventor, pushing the boundaries not only in telecom but now at the intersection of quantum computing and the nature of consciousness. So, James, welcome to the podcast.
Thank you.
Wow, I'm really thrilled, and as you see, a bit emotional about meeting you. I mean, I'm intimidated. This is really amazing, and we are so honored to have you, and really thank you for your time. You are a self declared wacky inventor, and I think we will taste a bit of that spirit during the podcast. So, since childhood, you've never been content with the status quo. And your philosophical and scientific inquiries, captured in your acclaimed book, and the title is like, wow, again, are the androids dreaming yet? I'm already dreaming of androids dreaming, I must say. Uh, the book is challenging the assumption of classical computing, and it delves into whether true intelligence requires a quantum substrate. I mean, there are so many angles from where I can start this conversation, but
Yep.
I'll indulge in a matter of personal interest for me because reading your book, of course, you are addressing the question of free will. And you examine whether humans are able to create and exhibit free will. And I have, of course, not only me, but I think we are all pondering with this question. And I read recently Determined by Sapolsky, which kind of I'm like, I want to stop my life right now because he makes such a strong point that we don't have free will. And I'm like, okay, now what? And then I read also recently Irreducible by Federico Fagin. I don't know
Mhm.
if you came across him, but
I've heard of it. Yeah.
he is definitely on your side, and he says that he kind of puts it in this way that the collapse of the wave function is actually a proof that we have free will, and that's when it collapses, when our will gets above the will of the universe, or however he puts it.
Mhm.
He puts it a bit more spiritual. Please tell us a bit. What's your take on this?
Free will. Okay.
Free will.
So the first thing is that um, I observe that I have it. Now, this is a very dangerous start to this question because the late Daniel Dennett will say, that it's an illusion, James. You're delusional. You don't have it. You just think you do. But the first thing is, just going through your daily life, it feels like you have it. Okay. So the first question then to say is, what physical laws would I need in order to support what I observe and see, which is that I do in fact have free will? Now, of course, we have this problem that broadly speaking, most of the laws that we know today don't give us free will, right? And in particular, quantum mechanics doesn't give us free will as we know it today, with one exception, right? So as we know it today, quantum mechanics is entirely deterministic theory. that just evolves in a very, very nice linear equation and so on. And the only puzzle with that really is the collapse of the wave function. It's when it moves from being a linear equation to suddenly snapping one way or another. Now, some people just say, it doesn't snap one way or another, and two universes move on, in which case you sort of don't have free will, but if you could choose which universe you went in each time, you would have free will. And then the other camp is that there's some form of collapse. If there's some form of collapse, the Schrodinger equation breaks down and does something different. And if it breaks down, it's not linear, and you can then go into lots and lots of arguments about why you would have free will. But I prefer to go head on with the true believers. So let's take a true believer. A true believer will be Sabine, the YouTube person. I always butcher her name. It's sort of Hoffenfelder, right? Or
Yes, yes.
Hoffenfelder. I can never. Anyway, and she's a full-on, determinist, right? That basically we live in a block universe, and everything is absolutely determined, has always been determined, and always will. And the four dimension of space-time are completely set. But you have some information problems in that. So in that completely set universe, we come up with non-computable solutions. Penrose, triangle, tilings, things like that, right? So then I think, you either say, well, the block universe is wrong. We live in a universe with free will, and it's not certain what will happen next. Or you could say, well, we live in a DVD, right? A filmmaker, a great filmmaker, the Avatar guy, James Cameron, right, made the DVD, and we're watching the DVD, right? But then you just have to put yourself back and say, well, there was a free will creation of what I see now, and that was when the DVD was filmed, and the actors decided what they were going to do. It is possible we're just watching a replay, but I think it's very unlikely. It doesn't feel like it doesn't behave like it. And it doesn't solve the problem, which is, how is a universe created that has these non-computable things in it if it's just a deterministic block universe? How does it compress all that information? Where does it store it? To me, it just doesn't work. So I feel I have free will, and I observe it, and I'm looking for the laws that would support it. And there is at least this hole in quantum mechanics where we see something that is not linear and is not deterministic and predictable, or at least is not predictable. And we also know that general relativity is wrong because it's not quantized, and there are all these singularities appropriate for the singularity people, right? But there are all these singularities that are not renormalizable. You can't just wish them away by changing your coordinate system. So it's incomplete. So we have an incomplete quantum mechanics and an incomplete gravity, and we're going to have to fix that. And it feels to me that a way of fixing it should give us an explanation of why we have free will.
Mhm. Fascinating. And of course, I mean, the jury is still out. Yes, as you see, like really solid scientists are on your side, like Fajin and many others, of course, Penrose and so on. And other scientists are on the other side. So it's quite interesting to follow that. Like, yeah, as I mentioned, I don't know if you read Determined by Sapolsky. I mean, it's really another mind-blowing book, and it was quite depressing, yes, to I mean, he was debated, of course, by all these other ones on the other side, and he, in my opinion, won all the debates. But anyway, the jury is out, and let me go on, however, to ask you. As a co-founder of the Penrose Institute alongside Sir Roger Penrose, wow, wow, and more recently, a founder of Valleys Corporation, you are developing a quantum biocomputer that could unlock non-computable forms of intelligence and maybe, would help us answer this question ultimately. Your company is taking an unusual approach to AI by merging biology with technology. Can you tell us a bit about your large brain model and what is your approach versus the classical computational approaches?
Okay, let me give you the elevator pitch. I did actually do this in an elevator, and the guy was so surprised, he got off on my floor, stepped out, and said, I've got to hear the rest of the story.
This
Okay.
let me tell you, this will work for us because I've recently been asked by our marketing team to reduce our podcast to 30 minutes, and I'm like, okay, this may work, but not for all of them because we have some deep questions here. But if you can answer this deep question in an elevator pitch, that's fantastic. Okay, let's see.
Okay.
Let's see if I will be
Perfect.
content with the answer.
I send brains to space. Okay. What we do is we take a skin sample from you, we revert it to a stem cell, we promote it to an organoid, and we send it to the ISS for 30 days. When it comes back, splashes down in Florida, we pick it up. The brains, the little tiny brains that we've made out of your skin cell, they're about 5 millimeters in diameter, have aged, and they have aged cognitively 10 years, and they've aged biologically 80 years. So I can take your skin and I can tell you if you get Alzheimer's when you get to 80. And I can also uh, apply drugs and therapies to that Alzheimer's brain and see if it works a bit better or whether the drugs I'm applying are toxic. Now, I'm okay, so I've probably got your attention now because that'd be quite a useful thing to do.
I already am writing 10 questions. Okay, go
Now,
ahead.
I've given you a nice, simple explanation. There's a lot of difficulties and problems and more detail to it than that. But that's the basic idea. So we get these brains back, and if you put them onto a little miniature EEG, which is called an MEA, a microelectrode array, you can actually read out their operation. And if you compare that, it looks like a 10-year-old person, right? And so you can say, well, that brain has matured to a 10-year-old. And if you cut into it and do a slice and so on, you can actually see that its dendrites have extended, the synapses are connected, it's pruned the unnecessary one, and it looks like the sort of brain that you get from a 10-year-old. Now, this is very useful because I have it now on an MEA, and with an MEA microelectrode array, I can put information in because I can stimulate it and I can read information out. So I put a little 1 volt spike in, I read out this tiny little spike as it thinks. So I can teach it to remember. I can teach it to walk a robot around a room. At the moment, we're not very good at it. We can try and the idea is it should go around a maze and it should remember everything and so on. But at the moment, it can remember how not to bump into walls and so on. But but we have the basis of a computer, which is memory and processing. And of course, the thing that we're using is actual brain. So we're all Ben really kind of recoined the AGI term, and we're all marching towards sorting this AGI thing out. And the one thing we do know that has AGI is a human brain. Well, I have a human brain computer, so I have AGI almost by definition. Again, lots of things to resolve and fix and so on. But that's what I have. I also have a brain that, when we use it, displays free will, or at least it displays
Wow.
free will and we experience free will. Right now, Daniel Dennett could be right and I'm delusional. Okay, so I accept that, but we have that. The other thing, of course, is that the scientific community, Roger Penrose basically said, I think the brain is quantum. In fact, Roger said, I think the brain is quantum
Yes.
gravity, gravitized quantum, he prefers it.
Yes.
Um, and until last summer or so, the vast majority of people, if you said, I think the brain is quantum in polite society, would walk you to the door and consider that you were a bit mad. And then the whole community flipped around end of the last summer. There were a couple more papers came out that showed that you get super radiant transmission of energy along a microtubule. So it's like quantumish, the same sort of not zero resistance, but less resistance than you would expect, and linear, not reducing with distance, that you get in photosynthesis. And suddenly you got Hartman Nevin and Christoph Koch, people writing papers to Nature saying, we think that the brain, consciousness is a quantum phenomenon, and that what we're going to do is to make a brain computer interface device, stick it into your brain, and then maybe if we could stimulate it with quantum entangled stimulations, we could give you the same effects as taking LSD or something. It's like altered states of consciousness. So the whole community has flipped over to now, well, it's probably quantum-ish in a same way as
Okay.
photosynthesis. I think most people say it looks like it's a quantum-ish phenomenon. And by quantum-ish, you got these. I mean, everything's quantum, right? The whole fabric of the universe is quantum. When we say
Yes.
something is quantum, we mean it's exotically quantum. It displays superposition or entanglement, spooky action at distance. These sort of weird, really weird wave particle duality type quantum things. Quantum-ish means it sort of does this superconducting thing. It's not superconducting, but it uses quantum tunneling to avoid the resistance that it would normally see, but it uses all classical noise to bounce that quantum tunneling along. So that's this quantum-ish, which is the electrical signals propagate in a way that they shouldn't propagate if it was just a classical resistive wire. So yeah, and that paper came out, and now everyone's saying, well, it's probably quantum-ish, and some people are saying, well, consciousness is quantum. And Roger, of course, and Stuart is saying, well, we always said, consciousness is a quantum gravity effect. So, thank you for at least accepting the quantum part of our theory.
Yeah, so and of course, as I mentioned, many scientists are doing that. But we kind of went a bit in the weeds here, and of course, we are Singularity Net. We are we are AI experts. But I must say that I mean, some of the terms which you used are above at least my blonde head, and I'm sure above many of our audience heads. Maybe not, but as far as I know, having had this podcast for some time. So I'm going to take you a bit back to explain a few things. So I have the first question is, and sorry for that and for my ignorance, but how long do you keep these brains in space so they age?
30 days. So
Okay,
they
so in 30 days they age with 8 years or 10 years, but I mean, why? Why is this happening
10
in space
to
faster?
80 years, 80 years,
Whoa! Okay,
not
tell me.
8.
Okay.
Uh, why? We don't know. We have hand
Oh,
waving.
but how did you have the idea then to do that?
Someone just thought it would be a cool idea. I mean, we know that send biological samples up, they behave differently and things crystallize differently. So someone said, well, what would happen if we send a brain? In fact, it was Eric Berry.
Oh,
So
wow.
why don't we send a brain to space? So,
Okay. I
you
mean,
know,
it wouldn't be my idea
and,
that soon. Okay.
and
Wow.
most people thought it was a bit nutty, but enough
Yes.
people put the money up and it went to space and it does do something very different. So
Amazing.
what we think happens is that any molecule on planet Earth has
Mhm.
to do something to stop itself, to hold itself up against gravity, right? Even if you're in a swimming pool, when you're in a swimming pool, you're not weightless.
Yeah,
You're being
yeah.
supported
Clear,
by the
clear.
water, right? Okay, so that's a molecule that's sitting around in your body is having to, use some of its energy to resist gravity. So you take gravity away, and you're in microgravity. Suddenly, the molecule relaxes a bit. Now, what would happen if a molecule relaxes? It can dock in a different way to other molecules. So it could react in a different way. It's got some more energy available. So it might be able to be more reactive with things than normal, because normally it would be using a lot of its energy just to sort of stand up. And now it's got some spare energy, so it can go off and do more things. So this is like very hand wavy, and clearly we're doing
But
some
you see, I
significant
mean,
study
yeah,
on
I don't want to interrupt you, but I just want to say that, I mean, for me, the intuitive thing would be, if at all, I mean, I would stay younger without gravity versus getting much older, and that's why it's kind of for me counterintuitive that they age faster in
it.
space.
Yeah, and it
And
happens to astronauts. So the next question is, oh, does this happen to astronauts?
oh,
Yes. So there's a thing called a
oh,
twin study that NASA did. There's an astronaut who has an identical twin brother, and
huh,
they do cognitive tests of the two astronauts before and after one of them, of the two brothers, before one goes to space and the other doesn't.
yeah,
And the brother that goes to space has a significant cognitive, um, sort of negative effects from
aging,
going to
whatever.
space,
Yeah,
right?
yeah.
Well, he's grown up. I mean, he's 30 or something, or now probably 50, but so he's fully grown up. So he's
But do
not.
they come back with an 80-year-old brain? So that's my question.
Well, they a little bit, yes, is the answer. So
Hmm.
the aging you get in space is not just classical. aging that we have on Earth, where everything kind of goes the same rate. Some things go fast and some things go slow. So one of the things that goes very fast is inflammation. So when you look at, if you've got an aging uncle or whatever, their eyes will be red, right? The area around the eye will be red, and they'll be a bit sniffly and things like that. And that's because as we get older, we get more prone to inflammation. So what you find with the brain is that when it comes back, when the organoids come back from space, and when astronauts come back from space, their inflammation is much higher. They look like they've got a virus,
Oh,
a
wow.
cold, or a flu or something. And so, if an astronaut comes back, you treat them in the way that you would treat someone who has a cold or flu. I'm to some extent the same with the organoid. You look after them and give them glucose and calm them down, and you could give them non-steroidal anti-inflammatories if you wanted. That's certainly what you do to an astronaut. We don't. I don't think we just let them kind of calm down and recover. But that's one of the biggest effects that we get. But there are also some physical effects. You lose bone mass and things like that, and muscle mass. Your brain floats
That
up
I
to the
would
top of your brain.
understand. Yeah, bone mass. I would
Lots of
understand
stuff.
because gravity has an effect on that, right? So
Yeah,
yeah.
yeah.
But
It's
the
actually
aging.
pretty bad. It'll be one of the most significant problems to resolve to go to Mars if we want to go to Mars.
No, but the thing is not that. The thing is that is not counterintuitive, like the brain, that the aging
Yeah,
of the brain, right?
yeah.
Anyway, okay, so let's move on. I mean, you are developing a large brain model, yeah, which will
Yes,
couple thousand miniature brains using this quantum entanglement, which your theory, yes, quantum entangled photons, I think, yeah, to form a
that's right.
biological quantum computer, right?
Yeah.
Okay, and one thing which I think our audience can relate with, if we can disclose this, you want to use blockchain technology, proof of brain, to validate certain computations. Is this so? Or if you want, we can just take this out from the discussion and move on.
No, no, we are considering doing it, right? Which is we do a couple of things. One of the things is we
Proof of
get
brain. How does that work?
well, we get it. I mean, the thing is, if you give your brain to this machine, you would like to be rewarded if that grey matter provides value in the future. So you want to record that. The other thing is there are a lot of medicines out there that we would like to test on the brain to see whether they are good medicines. And the place where we have the most neurologically active substances sort of in nature is the Amazon jungle. So we know that the shaman of the Amazon jungle have a huge oral tradition of different plants and herbs that have different effects on mood and brain function. So in
That's
that instance,
right.
we would record that in a blockchain so that we can reference back to where this idea came from, because you've got two things. You've got a substance, a plant. You've got a chain, right? You've got a plant. You've got some indigenous knowledge that plant helps with this thing. You then isolate a bunch of chemicals from it, and you discover whether there's a chemical you can isolate that has the effect that has been described by the oral tradition. And then you've got to go through the science of actually applying it to a physical brain, which you ideally would do with brain organoids to start with, because it's your best model. See whether it does what we think it did from the oral tradition, and then eventually it would become a drug. And when it becomes a drug, you want to reward the people who had the original indigenous knowledge. And so that feels a natural sort of blockchainy type record, because it's an international record. Why does blockchain exist? It exists to deal with trust, right? The original Bitcoin paper is you could have a central authority, but what happens if you don't trust an authority? You don't want to have to do trust. What happens if you want to agree between you? And that's where you use a blockchain. So if you've got a situation where Brazil is providing intellectual property to America, which then is going to Europe to be turned into a drug, and you want to track all that and make people very comfortable, you don't necessarily want to have a single authority like the FDA or the Brazilian equivalent or whatever says, yes, this is how it is, right? Well, single authorities very often have rather bizarre views of the world, or certainly views that very much favour their nation or their group of people.
Okay,
So
I
so
get
I
it. I get it.
we are working on it, and I think we probably will do some blockchain work on it for the record.
So yeah, but then how do you integrate this organic quantum system with traditional software architecture like blockchain and stuff like that, and decision making, and
Well,
or
that's easy, right?
that's
I
going
have a
too far?
computer.
Uh-huh.
I have a computer, and I'm going to use that computer to do computation. Blockchain is computation, so I can use,
Correct.
I can use an adiabatic computer, a quantum with blockchain. That's always free to me to do. The interesting thing, of course, is if the brain is a quantum computer, a single organoid, which is 5 millimeters diameter, is 5 billion gate equivalents. So you've got a 5 billion
Oh,
parameter equivalent quantum computer. At the moment, the record is, I think, D-Wave with 8,000 bits for a sort of, adiabatic type quantum computing, and let's say IBM with 1,000 bits on the superconducting side. So you've got something massively more scalable. So why would that be an issue? Uh, elliptical curve cryptography. You got a billion parameter quantum model. You can break Bitcoin addresses in seconds,
yes.
right? So I
Yes,
put my hand up.
yes.
Southwest was saying, "Oh, it's 20 years." I said, "Well, what's the chance there would be someone that might have an end run round the current, um, you know, why couldn't we have a deep seek moment? You wake up one morning and someone's found a way of making a quantum computer that is massively scaled. And they announce it and say, oh, we've done it. We have a massively scaled quantum computer. What stops that happening? So I really think that the crypto community absolutely need to get ready for a deep seek moment for sort of encryption and so on, and be absolutely ready for it now, not saying it's in 20 years' time.
And
It might be
given
in
that
20 years'
you,
time, but when it happens, it's going to be overnight. you know, it's going to suddenly be
yes,
that.
it will take us hopefully not by surprise, like let's hope, but of course, as someone who built a quantum computer in their garage during a quantum gravity computer during COVID, I think you may become the most dangerous man for the crypto community
Well,
at some
yeah,
point.
so the professor at Austin University said, "Oh no, no, we'd know about it." I said, "No, you wouldn't, right?
Yes, yes,
I mean, I worked on a quantum computer in my garage for 2 years. No one knew,
exactly. No one
right?
knew.
No
No
one
one
had a
knew.
clue,
Yeah.
right? You cannot protect against a deep seek event,
Yes. Oh, that's
or
very.
you can
Thank you for
you can
this.
protect. It just at the moment, people are just going to kind of ignoring it, say, "Oh, it's years away."
Exactly, that's a problem. Yes, yes. Well, now, as far as I know from him, you are working with Dr. Ben Goertzel on the neural organoids project. And I mean, in a sense that he is interested to train those neural organoids to do precognition, like in Minority Report,
Oh
precogs, and
yes,
yes, yes, and find which neurons are doing the variant quantum mechanics stuff that lets precognition work. And this is another fascinating angle. However, it turns out that you and Ben don't see eye to eye on certain issues. And with this, I feel like
certain,
delving into a
only certain. Carry on.
exactly certain issues. And so of course it's unfair not to have been on such a twist in the conversation, but I think we should delve into a series of questions that I would open the possibility, which I discussed with him, to have a rerun of this podcast, having Ben as well,
Oh yeah,
uh,
head to head
to
would be
level
great.
the playing field, right? Okay, okay. But are you up for a few questions
Sure.
now
Yeah,
in
yeah,
this regard?
yeah.
Okay.
Sure.
So let's talk about of this friendly feud between you and Ben. And I know that it is friendly because he really appreciates your work so much, and he really hopes to use those organoids. And but he believes, as we all know, in SingularityNet, that AGI will emerge from classical computers with enough neural symbolic magic, as he calls his methodology,
Yeah.
and software complexity. And you argue that, well, no, that without quantum gravity, you're just faking it. And again, yes, Fagin and of course, Roger Penrose and Hameroff and all these titans agree, are on your side. So tell me your side of the story in this regard. I mean, what would be your argument, like in a debate with Ben? I'm not
Yeah,
saying that to prepare Ben for the next podcast, but I think your
yeah.
audience would be very interested in your angle.
Yeah, no, I did what old physicists did 100 years ago, and I wrote him some letters, and he wrote me some letters back. So we actually have letters backwards and forwards of the argument. So,
Oh,
this is it's a friendly but and rather, I wouldn't say formal argument, but a thorough argument and discussion. Yeah, we disagree, right? So it's an argument, but not in a nasty way. So, for me, the fundamental thing is that you see mathematicians, and you have to. And I'd love to do this with jazz or something like that, right, or a painting or whatever, but we don't have any rigorous way of analyzing a painting or analyzing a piece of jazz music. We'll put that to one moment. Maybe we do, but anyway. So you have to with mathematics, and what I say is that you get certain mathematical results that are non-computable. And what happens with one of those results is that you needed to add an axiom. So we have, mathematics is basically, axioms and rules of inference. So you say, okay, when I add two numbers together, 1 plus 1 equals 2. And I'm going to create a counting axiom that says, when I take a number and add 1 to it, it makes another number. And that another number is 1 more. And that would be my axiom of counting. And so you have these axioms in mathematics that are defined, and then you build, or every other piece of mathematics is built on top of that by either taking an axiom and then moving the symbols away and say, a plus b equals 1. So if b is 1, what is a? And you can rearrange the symbols, you can work it out, right? So that's a rule of inference. And most theories that you come across, you can just do with the standard axioms that mathematicians have. But every now and again, you need a new axiom. So there's a Roger's famous example is Goodstein's theorem. So it's a Goodstein's theorem could be proved if you add the axiom of transfinite induction. Oh my God! Okay, I've lost the entire room. But anyway, just take it as read that there's an axiom you have to add, and if you add it, you can prove it. And if you don't have the axiom, you can't. The problem is Gödel. If you remember, Gödel had the incompleteness theorem. He
that we
said,
know. Yes.
okay, he said you cannot add an axiom computationally. There's no computer can add the axiom. Why? Because the computer can't decide whether that axiom makes sense or doesn't make sense. Which is that now we're into this philosophical thing, right? Roger, uses the word understanding. I'm going to use makes sense.
Mhm.
And so there are axioms that make sense in our universe and axioms that don't. You can make whole bit branches of mathematics out of axioms that don't create any errors, right? There's no syntax error like in a computer. Syntax error. This is this is wrong. It won't give you a syntax error. It just meaningless. It doesn't represent the reality we live in. And there's an infinite number of axioms you could add that are correct syntactically but meaningless, and an infinite number of axioms that you could add that are meaningful. And the problem is a computer cannot tell the difference. That's the halting problem, right? Cannot
Mhm.
go through and say, right, this is a sensible axiom, I'm going to add it, bing, I've done it. That would solve the halting problem. And Turing said you can't solve the halting problem. So you have this Turing Gödel thing that says you cannot add axioms because you can't decide whether they make sense. And a mathematician is going to have to add an axiom and go, I understand that this axiom makes sense. I am adding this axiom because it makes sense. And I can explain to another mathematician it makes sense. And all the mathematicians will agree, yeah, you're right, makes sense. And because I've added this axiom, I can now prove this. I go, yeah, you proved it. It is self-evidently correct. We all agree. But you could not have done it as a computation. That's something that's not allowed. And that's where the gap is. That's the nub of the problem,
I
right?
think you made a clear point, which, no pun intended, makes sense, at least to me. And I wanted to ask if you have any quantum litmus test for real awareness, and
Oh,
or this is it, or this is it. Yes, this is it. Your pillars with Gödel, and that would be
yes.
enough to
Okay. I
to
mean,
to show that Ben's approach hits the wall, for example.
well, if a computer unaided by a human turns up with a solution to, I think probably the Riemann hypothesis is something that is non-computable, right? You will need more axioms, but if it turns up with a proof that by adding an axiom, says, right, here's a self-evident axiom, I've proven it, all mathematicians agree, right, and it was unaided by a human, then that's probably your sort of Turing test, your non-computable Turing test. So computer's done something that I would have argued was non-computable. Now, I would obviously immediately go, I bet you helped. I bet a person got involved and helped here and you cheated. And
Hmm,
there'd be
hmm.
lots of arguments around that. There'd also be quite a few arguments about whether um, the axiom was strictly speaking needed to be added and all sorts of things like that. So it wouldn't be a quick conclusion, but that would be where the test would be. You walk up with a proof and say this is a clearly non-computable proof, and there are like 20 or 30. You go to Wikipedia and say, or actually now ChatGPT, and say, give me a list of all the mathematical theorems that have been discovered that required an additional axiom that couldn't have been derived just from pure arithmetic, and it will give you 20 theorems that we've already done, including four-color conjecture, Poincare, and so on. So my argument is human mathematicians are constantly coming up with these non-computable proofs. Therefore, humans are non-computable.
Hmm.
QED.
Well, that's fascinating and somehow reassuring. It makes me feel more special, you know. So,
But I might
but
be wrong. And Ben thinks I'm wrong.
Ben is hoping you are wrong. I'm hoping. I do not know what to say.
well, but Ben's, but he's also going to buy one of my my organoid computers. So
Definitely,
he's hedging his bets.
definitely.
So he'll
But for
he
his precog thing, yes.
Well, you might sneakily use it to do a bit of computation. And it goes, "Oh, I've got the Riemann hypothesis." And I go, "Did you use my quantum gravity, my brain thing?" And he goes, "Oh, I might have." I said, "Aha, got you." I'm
Got
not allowed
you.
to do that. Not that. That's breaking the rules. You have to use only silicon. It mustn't have this brain feature. And maybe what
Yes.
happens is I build my computer and it's widely deployed on the internet, and it's just impossible thereafter to say you did this without the benefit of organoid computing because it's such a ubiquitous thing that you know GitHub is full of axioms that have been proposed by my sort of computer, and then if that once the axioms in GitHub, you go and get it, you know so it may be there may be a brief window where you can actually do this type of Turing test where you say we did not use any human being to do this, or
Wow.
organoid or silicon version of the organoid, because I'm not saying that brain matter or living matter is totally unique. I'm just saying it does something very clever, physically different, and if you wanted to build that in silicon, it'd be a lot of hard work. We've evolved
Yes,
something
and
that does it.
I think we may need to wait a few years until we give the verdict, because the proof is in the pudding. Yeah, so if we get there
Yes.
in one way or
Yeah.
another, and to wrap up this quantum versus classical quarrel, I just wanted to ask you, how serious do you think this is? I mean, are you and Ben reaching the same destination in the end? What's your kind of prediction? Or is this a fork in the road that splits intelligence into two completely different worlds, simulation versus what you call, I think, presence? Or maybe I'm biased because I had Kern Frost with his spiritual intelligence on the podcast, and he said, well, true intelligence is ability to hold presence and not only computation.
Interesting.
What do you think? Yeah, yeah.
Well, I
So
mean, there are a few different ways of describing it. I mean, natural intelligence I quite like. Um, I don't like hypercomputing very much because everyone gets everyone's hackles up. But hypercomputing is clearly, one of the terms for it. But I mean, natural intelligence I just find a much easier thing to use as a term without getting into lots of weird arguments. Um, so yes, I don't think it'll be a fork in the road in the sense that I think we're going to have biological intelligence available on the internet to plug into systems within the next 60 to 90 days. And once that's happened and it's started to feed GitHub, it's going to be impossible to take out. So you're going to have to make incredibly detailed. You're going to have to make the same sort of arguments you have to make, experiments you have to make with precog. You have to absolutely prove that you didn't cheat, uh, accidentally or deliberately. You didn't actually give the information to the other party by some non-precog method. And that's going to be hard. So you're going to be able to have a air-gapped computer buried in a salt mine that comes up with a solution to a Riemann hypothesis, and you definitely know that no fragment of a non-computable axiom was fed to it and it came up with it on its own. It's going to, in even 90 days time, the rules around getting this, making a proof of this are going to become much more difficult because we may have ours up and Final Spark may have theirs up. There are competitors in this field, and the Australian guys may have theirs up. I can't remember what their name is, but I'll come to me in a second. This is the problem with being a human. I want a BCI with a perfect memory chip that just chimes in and goes, James, it's, Cortical Labs. So, thank you, Cortical Labs. Right? So I definitely would like to be a cyborg. I would be terribly useful to have a co-processor sort of chat GPT in my ear. I mean, obviously I have chat GPT here, but it'd be rude
we
to
can
use it
have
while
that now. Yeah, I mean.
we almost have it. The interface is not good enough, but
Okay, that's a different matter. That's true.
well, so the
we,
glasses that the Meta
yes,
glasses. If I was wearing the Meta
yes,
glasses while I was talking to you, everything I was saying, it would just be printing up in the top right hand corner. Oh, the definition is this,
yes.
the list of
And
this
I
is
would
this,
have the questions written on my glasses, and I wouldn't
and
need to
we would
even
just be
think
automaton.
about.
We would just, I am just saying what my glasses are telling me to say to you.
Yeah, exactly. Yeah, speaking of that kind of cheating, right?
Yeah.
So, I before I delve a bit deeper into your experiments, I'd like to ask you because I think I read somewhere, or maybe I'm fantasizing here. Did you? I think you kind of solved the halting problem with your quantum computer. Is it so? Like,
Halting
do you have
problem. No,
any? Okay.
we did a demonstration that we thought that we got a demonstration of objective reduction, i.e., gravitational collapse, which is
Right,
that
so that's Sir
yes,
Roger Penrose is yes. So tell us a bit about that. What did the experiment involve, and what it revealed about the wave function collapse, and whatever you want to share with us?
well, what we did is we
Not too deep. Not I
no, no,
mean
no.
as much as you can for kindergarten kids.
Yeah. Well, the question is, if you have a, it's not going to be easy for it's not going to be quite kindergarten level because we are talking,
Of
we are
course,
in
we are a
quantum
bit
land.
more advanced.
I'm
Yes.
afraid I can do quantum mechanics for kids, and in fact, I met the guy that wrote the book Quantum Mechanics for Kids, so it
Oh,
is possible. It is possible to do,
I have
but
seen photos of
basically,
your kids in your garage when you were building that. Yes,
yes.
that computer.
But basically, the question is, you flip a coin, and this is a very bad analogy, but you flip a coin, and it's going heads to tails, heads to tails. So it's in a state where it's in two states at the same time. Now, in quantum mechanics, it's truly in two states, and in classical mechanics, it's spinning, and you could know there's hidden information that if you knew the rate at which it was spinning and which way it started, you'd know it. Um, and so the question really comes down to whether you, when you make a measurement do you get a collapse? So you take your coin and you slam it down on your wrist. You go, right, your heads or tails. Has it at that moment decided whether it's heads or tails? Or is it only when you lift your hand that you're going to know, right? And the question is, can you make an experiment that splits those two? And it's very difficult to do, but that's essentially what we did. So we put it into, we measured it, but we didn't collapse it. And then having
Uh-huh.
measured it, we then collapsed it. And the question, and if you collapse it, according to Penrose, so what we did a partial measurement. We say, right, we've got coin, we're going to measure half of it. Okay, we're going to know what half of its state is. Right, we'll leave the rest of it alone, and then we're going to measure it. Now, according to Penrose, if you measure it, the space time is in two different places, right? So when you measure it, you amplify up this uncertainty about space time, and the whole thing must collapse, including the bit you didn't measure. In other ways that you might think about quantum mechanics, if you have partial information, you look at it, it only affects the partial information you have. Roger's theory is this global, is this relativistic, right? You cannot have two universes. You cannot have a universe that's up and a universe that's down at the same time. You can only have one universe. So once you make a measurement, you amplify it up, and it hits the Heisenberg uncertainty principle, and it goes over it. So, right, I'm certain we have two universes. You can only have one of them, right? Which means the original bit, the original quantum bit, you haven't looked at yet, right? You've got two kids. One's got a spinning coin. The other got a spinning coin. You grab one of them. You say, I'm going to measure one of these. I happen to know that this one is the opposite of that one. So I've got, I'm going to measure it. If you do this measurement, the one that you haven't measured will collapse. And then you can look at it and say, oh, yeah, it has collapsed. And that's the experiment we did. And we put up the paper and announced it at Deep Tech Week. Lots of skepticism, a little bit of rudeness. Go and repeat the experiment. It's very easy to do. All the explanation is in the paper. You can. I will release the the GitHub, and you can just play with my code. Go and knock yourself out. Right? It's a very very
Fascinating.
very simple experiment, and it does show a nice repeatable result. And you can go and tell me that it's for some completely different reason, but it is at least an experiment that does that test on hardware that people spend billions of dollars getting right and cleaning up and making super cold and very precise and so on. So
Amazing. Your your explanation with the coin actually reminded me. I recently was of all in Bhutan with the renowned investor, angel investor Cyan Bannister. I don't know if you know her or of her. She's the first investor in SpaceX, Uber, and so on and so forth. And actually, she is very much into this kind of thinking. But her point was, I mean, at some point she said, I you will always wish that the coin falls on its edge, so you still have the choice for what branch will be. Is that possibility also in your cards, or that doesn't make
um,
sense?
no, we've got to remember the coin analogy is a bad analogy, right?
That's true.
Einstein would have loved it because he
Yes.
thought that there should be hidden variables. So if you had you ought to be able to have enough information to know which way the coin is going to land, right? Um, and it would appear that that's not true. There don't seem to be any hidden variables. The coin really is heads and tails at the same time, not spinning between the two of them in some sort of deterministic way. Um, so yeah, that's
Let us move a bit into another topic which is related to that. So let's assume you succeed in doing this uh, the conscious machine. Let's call it, because let's not call it a computer. Well, you call it a computer, that's fine. But okay, so we have it. We have this artificial consciousness running around in the universe. So on one hand, as far as I know, your team is working on many applications about that, like from creative design, immersive virtual reality, what you were mentioning here as well, financial market modeling, and even, as you mentioned, that you're improving. But on the other hand, such a machine, of course, raises many, many ethical and safety questions. So, what do you think? Yes, I mean, on one side, a rule-based system, yes, can obey the law, but this one, oh man, yeah. So, do you have any thoughts about that?
Well, the first thing is if Ben is correct, then the ethical problems I have are identical to his.
Uh huh.
Right? If you can do AGI in silicon with just
No, that's
computation,
true. Okay, now we're talking about both. Yeah,
yeah.
but let's say if we achieve this consciousness, I don't say like, okay, so if Ben has this problem, I can have it too. I'm just saying,
No,
how
no,
do
no.
we address it?
Yeah. So if you assume that um, consciousness arises from some sort of quantum gravity, which is first evident in biological systems, and you'd have to build some fairly sophisticated hardware to do it in hardware. Then you do have this issue that you might grow, you might make a conscious entity. So at the moment, of course, the organoids that we grow are very tiny and very simple. They don't have all of the complexity that a human has with an amygdala and a hippocampus and the various things that give us, fight and flee reactions and pain and all those sorts of things. I mean, we what do we worry about with consciousness? Well, we worry about, I suppose, erudite things and practical things, right? We worry about being in pain. We worry about worrying about being in pain in the future. These things we actually are scared of because they're scary. I mean, we would want to be clear that our organoids, or we're not worrying about that, and we're not subject to it since they don't have any pain receptors. A few, it's a fairly simple one to look at. And then you've got the sort of existential things, which would be basically the machine going, "Please don't turn me off. I'm conscious and I'm aware, and I like being aware, and please don't turn me off."
And misusing its autonomy to, turn us off eventually.
I'm much more worried about Ben's machines than my machines.
That's
Right?
okay.
Like
And
artificial
let's tell
stability
me,
is more
how
dangerous.
do we keep Ben's machines under control?
Well, it's when you start giving them agency, and we're giving them agency right now, right? The MCP stuff and so on. I mean, I caught myself about to give my credit card to a AI agent that I had made yesterday,
Mhm.
and I went, "Ooh,
Yes, good
first
point.
moment, right? Do I trust this thing with my money?" Now, of course, Ben's in crypto, right?
No, I'm telling you, no.
So, well, kind of, you to some extent you've got to. If you're in crypto and you're doing AI, at some point you're going to give money to the AI. I mean,
Well, let me tell you something. In like
inevitable.
about 20 years ago, I was involved in the multi-agent systems so-called movement. Yes, Woolridge, Jennings, and the whole point was about giving it agency,
Mhm.
intent, and curiosity, and everything. And of course, now we can realize those things much more elegantly.
Hmm.
But I just wonder, I mean, can I trust them? And this is actually related to the question, to where I was going with my question. So, what does it take to trust them? What do we need to do? Is there a framework you have in mind or stuff like that?
Well, with a machine like mine, I would teach it about ethics. Now, of course,
Oh,
with a machine like Ben's, I would teach about ethics as well.
okay.
I am someone who says please and thank you to ChatGPT and says well done when it does a good job. God knows why. I'm told by Sam Altman I'm actually polluting the planet in the process, but I'm gonna carry on because I want this thing, to the extent that something leaks through and it learns from me. I want it to learn to be polite. I want it to learn to say please and thank you, and I want it to learn to appreciate the work of others. And to the extent that I have to put some unnecessary words into my I can't. I'm English. I can't not say thank you to a machine that just wrote me a piece of code. I just can't do it. It's a pathological problem. Um, but
Okay, so you are teaching it that, and then Putin buys your machines, and it teaching it. something else from his values. What do we do
The
then?
issue, well, the thing is computation, non-computation. So if the computer is purely computational and you give it ethics, it's going to have computational ethics. If it's a non-computer, i.e., it can be creative in all fields. It's just that mathematics is the one that we can kind of nail it to the wall and say, okay, you did Riemann, you passed. Then it's going to be creative with the ethics. Now, I don't think. I mean, every human is creative with ethics, right? Let's be absolutely clear. Very often, in very good ways, it can solve complex ethical puzzles that computers cannot. That's an example where you see computation, non-computation sort of up close in a non-mathematical area. Um, so I just think that you're going to be better off with a machine that has that some sort of understanding and can understand how ethics go together, and might have to come up with a new rule that makes sense in context, that it can use and explain to you why it came up with it, why it makes sense to solve an ethical problem. Whereas the other machine decided to kill Granny and the aeroplane full of small children in in these horrible
Yes,
sort of
yes,
MIT ethics puzzles that they're given, right?
yes,
Um,
yes.
and I mean, I'm a hardened Star Trek fan. I always like the Kobayashi Maru scenario, right?
Same with me and Ben. Yes,
Yeah, and it's like, well, you're going to get AI, my sort of AI, maybe his as well, coming up with solutions to Kobayashi Maru. So I'm going to break the rules. It makes sense to do so. You didn't say I couldn't. Um, I don't know whether Star Trek they rewrote the manual to say you couldn't do it that way in the future. Probably did. Um, but anyway, yeah, um,
next year is 60 years of Star Trek, and I'm going on a cruise with William Shatner and Chekhov and
are
others.
you? Yeah.
Yes,
You do
yes.
all the cool things at Singularity. Very envious.
Yes, I'll send you. I will post the link also in the podcast description. But yeah, okay, yeah. So Ben
So I should
also,
do
yeah,
a
he has
plug.
a
Yeah, I should do.
Go ahead.
Well, you keep arguing. I want to do my plug at the end for the space mission.
Yes, we're not at the end yet, so we'll get
Okay,
there. So
that's
what
good.
I wanted to say is that Ben has a company called Mind Children. I don't know if you know about it, which is also taking that approach, yes, to teach the AI like from
Yes.
yeah childhood the right rules, the right things, and let's hope
Hmm.
they will. I mean, of course, creativity can be used in so many ways, right?
Mhm.
But do we have guarantees? How do we do that? I don't expect my kids will kill me anytime soon,
No.
so probably, yeah, probably there's hope in that regard.
Yeah.
And before you give us your last words and your plug, I wanted to ask you, because it's so exciting what you are doing, and you are working at the cutting edge, really cutting edge of research and technology. What advice would you offer to aspiring researchers like those in our audience? Or technologists and inventors or future inventors interested in exploring the intersection of consciousness, quantum gravity, quantum mechanics, artificial intelligence. What would be your advice for where should they put their efforts, or if you have any other thoughts for them?
Well, you should usually do something that you are passionate about, because if you're doing something you're not passionate about, you won't do it, right? So one is work out what, you know, someone was saying to me, what startup should I do? I said, what do you do at the weekends? He went, what do you mean? I kind of take time off. I said, no, what's your hobby? What do you do when you're not working? He told me what it was. I said, can you do a startup there? Because that you consider that to be play, right? Not work. It would be really great if you go to work and your work is the thing that you love doing. So the first thing is, if you can find something that you love doing, or a puzzle that you can't put down or whatever, that is a great place to start, because you will find huge motivation there. I generally like to build something, or experiment with something. Although didn't, I mean, I didn't know enough, and so I wrote a book, which I suppose is building something, right? So I wrote a book, And then at the end of that, I thought I knew quite a lot more than I did at the beginning of it. And then I started doing, building some experiments. But it took probably a year and a half of thinking to come up with an experiment that I thought would be able to sort of show an objective reduction, difference. And then another 2 years to do the experiment, and another 2 years to summon the courage to actually go through it with Roger and say, am I mad or not? Which he thought actually was quite a good idea for an experiment.
But yeah, but your passion for technology, I know it started in childhood. I mean, you shared in one conversation your adventure with radio waves and how you blocked your sisters from listening to
Oh
some
yeah,
music which you didn't like. So it's like,
I
and
hope
then you
they're not there.
continue that.
Yeah, that was a byproduct of a radio I made, and it just
Quite
so happened.
mischievous, I must say.
But thereafter, it was brilliant because if they were playing something I found annoying, I could just make it turn off.
Yes,
It
but
was a
I
radio.
mean, for you, it was great, but for them.
It was very funny.
Speaking of the ethics of AI,
It was very funny because, of course, I was the engineer. So they say, "Well, James, it's not working," and I go, "Oh, let me have a look and see if I can fix it for you."
right, right. Good
Awful, awful. So
inspiration for the conscious AI, right? Like,
yeah,
okay.
um,
Yes.
yes, a
Well,
little bit of mischief is not too bad, I
it is unavoidable with creativity, and that's
think.
right. Yes. So that's also, I mean, that's what leaves also this question with the jury still out on the ethics of conscious intelligence, conscious artificial consciousness, or however we will
Yeah.
call it in the end. Yes. So yeah, so thank you so much. I mean, James, really, it was amazing.